Hi guys, so today in this lecture we will study that what are the challenges we may face when we scale our server horizontally. Okay. So in the last lecture what we have seen there are two types of scaling possible. One is vertical scaling where we were keep on increasing our power of the server, but what we saw that we reached to a limit, right. Post that we cannot increase the capability of the server because there is a physical hardware limit, right. But to make the scalability even more prominent for more request, right, what we did the horizontal scaling, right, where what we added couple of more servers parallelly, right, and we connected them through a load balancer, right. This is what we have studied in the last lecture. So in this lecture we will understand what are the challenges we may face when we will separate our request to multiple servers. Okay. So what are the challenges we may face? This is what our topic of discussion is in today's lecture. Okay. So now we will first understand what are the advantage we are getting with only one server. Okay. Then we will understand what are the disadvantage of the multiple servers. So first, what are the advantage of having only one server? Just think. Okay, we have one server where your applications is deployed, right, your applications is deployed. Okay. Now a user is interacting, user request is coming to your server. So first thing, session management, I will discuss about session management, right. As your applications is deployed into one server, the session informations will only be stored in same server. So the session informations will be stored in the same server, right. So whenever a second request coming, you can get the session information because all the request is coming from the same server. So session management is very easy when you have only one server. Okay. Next is log, right. So as you have only one server, so what will happen? The log will come into your server location. Suppose I am giving var app log dot log message. Okay, just thinking. So in these locations your log will come, and when you will log into your sandbox, suppose this is a Linux server. So when you log into your Linux sandbox, you go to this path, you can get the required log, right. That for monitoring or for any purpose, issue debugging, you can get the log because it is in only one server. Okay. But when it comes to another advantage is, okay, suppose caching, right. Suppose you have some metadata, static data in your database, okay, which you want to use in some process in your applications. So what we do on the startup time, when your application is starting, what we get this data from database and we create one in-memory cache, right, in-memory cache, and whenever required we directly take the data from in-memory, we do not go to the database, right. So we reduce the database overhead by doing in-memory cache. So that also is very easy because your application is deploying into one server, and in this server the in-memory cache gets stored, right. So what we understood, one is cache, caching is very easy when you have only one server. Another is log monitoring is very easy, right, log monitoring is very easy. Another is session management is very easy, right. So when you have one server, you have lot of advantage, right, lot of advantage. Things gets very easy for everyone to work on this project because log you will get directly logging to the sandbox, you can directly get the log, right, you can directly get the cache, you can directly do all this stuff, right. Now when it comes to distributed system, that means when it comes to horizontal scaling, what happens? Just think about it. You are now deploying your applications in more than one server, right. Just I am considering only two server. This is a server 1, this is a server 2, your applications 1, and this is your applications 2. Okay. Now this is a load balancer which is redirecting the request from application to either server 1 or server 2, right. This is what we have seen in the last video. So what happens when a request is going, right, suppose user information is going and just to get, just you have a scenario that you have to maintain some session, information, suppose login credentials or something, you have to maintain some token in session, something you have to maintain. So, in that case your first request from user suppose went to the server 1 and you created one session object here, okay. You created a session object here and you stored some data in your session memory, right, in session attribute. But when the next request goes, load balancer may send the request to the server 2, right. So, what will happen, right, when your code will try to get the session attribute, it will get null, right, because the session we stored in server 1, not server 2, right. So, what will happen, your session attribute, this particular server applications when it will run, it will not get it, right. So, this is the big problem, okay. We cannot get maintain sessions in individual server, right. So, what is the option? What we have to do? Either we have to manage the sessions outside of the server, right. Either we have to manage outside of the server, so that each request comes, any session related details we can get, each server will get from outside of the server, that way we can maintain. Otherwise, we have another option is each user, when the user request will go for one particular user, we will do such a way that for one user the request will always go to one server, right. Suppose user Amit is logging in, so this request will always go to server 1. Suppose user Osit is logging in, so this particular request will always go to server 2, right. So that what happens, the user information session details will always be storing in that particular server where this user request will be served, right. So, this way also you can solve the problem. So, what are the possible options we have discussed? Either we can maintain the session details outside of our server and any session related interactions the applications will do outside, it will connect to that particular outside server and it will get the details, right. Another thing is we have to maintain such a way that one particular user request will always go to one server, right. Next user request will come, it will always go to S2, right. So, this way also you can solve the problem. So, this is what it called sticky sessions, okay. What that is called? Sticky session. So, what sticky session means? That this load balancer maintain a sticky session where this load balancer is responsible to send one user to always one server, okay. What happens? So, sticky sessions what? Load balancer maintain a session where, right, if you enable the load balancer for sticky sessions, then load balancer will maintain that one particular user request will always go to one server and another user request will always go to different server. So, what is happening? Suppose there is a scenario now, just think about it. When I am telling the scenario, think about it, what can happen, okay. Suppose we have 2000 user, right. So, for these 2000 users, 100 user now getting served by S1 and another 100 user is getting served by S2, right. So, this 100 user may be time zone specific. Suppose this 100 user is from India, this is just a hypothetical scenario I am giving, this 100 user is from US, right. So, when they will use their application most of the time? In India time, night time, right, and in India when they will use most? Daytime, because India's people are most active in daytime. So, what will happen? Your load balancer for India, whenever someone is trying to access the request, the load balancer will always send to server 1. So, in daytime the load in server 1 will be very high compared to server 2, because server 2 will not get any load at the daytime, right, because everyone is accessing from India. Same in the night time, server 2 will get heavy load where server 1 will have less load, right. So, what will happen here? The load is not getting distributed, uniformly across the server. So, what happens? If you enable sticky sessions, there is a chance right, there is a chance that your servers, one server will be heavily loaded, one server might be less loaded, right. So, uniform data, uniform load separations is not happening if you enable the sticky sessions, right. Rather, you can maintain a session, details in Redis, okay. So, if you do not know Redis, that is fine, just think about it, think in such a way that a session details is maintained outside of your server somewhere, right. We will talk about Redis later, what Redis is, what is this, all these things we will talk about it, just outside of your server, okay. So, any session related details a server want to get, it will get from Redis, it will get from outside of your server. So, this way it is better to solve the problem. So, next, what is the next issues may come, right. Now, this particular request where the session details needs to be stored, is called stateful, right, stateful request. So, where the state of the request has to be stored somewhere. Suppose a user AD is logging in, right, and after logging in he is getting a token, right, he is getting a session token. This session token, in the next request, this session token will be traveled to S1 or S2, right, and this session token will be validated, right. This session token will be validated whether this token is still active or not. That means it will make sure that this AD is still logged in to get the response, right. You got my point? Is little complicated topic. Suppose one user AD is logging into your applications. So, when he will try to log in, he will get a login token, right, session token, right. So, this session token, when the user request will go to any server, this token has to be stored somewhere, right. If this token is stored in S1, somewhere in S1, then the next request when it will go to S2, it will not be able to understand whether this request is already logged in or not. So, this automatically it will get logged out from S2. You got my point, right, because the response will not come properly. So, when next request will come to S1, automatically it will get a response. So, the user experience will not be proper, is not a correct, right, correct user experience. So, if in this case, if you can maintain outside session, at least this token will be saved somewhere outside of the server, then whenever session details will go to S2, S2 will validate the token from outside, S2 will validate from outside, so that what will happen, at least the user will get proper, response. Next thing is, another type of token is also there. We will talk about all these things in detail later. I am just giving you a high level idea what is the problem that may come. So, another is the stateless request. So, where we no need to store any state of any request, right. Ideally all the HTTP requests are stateless request, but still we had to make it stateful to make the user keep logging in. So, across when they will use the applications, right. Otherwise, the user have to log in each request, right. That is not a good experience, right. That is why we had to make it stateful. But there is another type of token is also there which can help to make the whole request stateless and give the user same type of experience, that is JWT token. Okay. We will talk about it later. Okay. There are two type of token, one is JWT token, another is a session token or opaque token. Okay. This opaque token or session token we have to store it somewhere and get it validated, but JWT token, it carries all the informations inside this token encrypted way, so that applications can decrypt and it can check whether the user is already logged in or not. Okay. If you are not understanding this part, don't be confused, I will make separate video on that. Just making you aware of that there are two types of token we can use to make this stateless or stateful pro request. Okay. So, I hope you understand till now what is the session related problem may come, right. Next is the log, right. Next is log. So, what is happening? So, when you have a distributed system where your applications is deployed in more than one server, right. So, more than one server and load balancer is balancing the load, right. So, when the applications will run on S1, the details of the log will come in here in this folder of S1 Linux server, right. And when it will run on X2, the next request when it will come to S2, it will again be here right. Now, when a user will log into your applications, he may send 1000 requests, right, in his life cycle, right. Before he logged out from your applications, he may send 1000 requests to your server to to process, right. Now, which log will go where, you never know, right. Now, to check the log, you have to log into 2 sandbox, right, and you have to check the log, right. For 2 also it is okay. Now, just think about, if you have related 40 server, it's 40 horizontal server is serving your request, then how will you manage, right. You cannot log in 40 different Linux server to get your log, right. So, this type of issues is there when you have a distributed system. To solve this, right, to solve this, there is a log streaming is there, okay, log streaming. So, what we do, I am just telling you a high level, we have a log stash or any agent is there installed in each server. So, what it will do, there is an agent called log stash, okay. So, this log stash agent, whenever the log will come here, it will push this log to one common data storage, I would say, like Kibana. There is a ELK stack available, okay, Elasticsearch, Logstash, Kibana, okay. So, here also it will go there, right. So, at least the log will be stored in a centralized way, right. You no need to log into 40 different server and check the log. Now, another problem is there, right. Suppose one request is traveling from here to here and the next subsequent request is traveling to S2. How will you understand in the log that which request is served by which machines or how the flow is there, because the log will not come in flow, right. Because why the log will not come in flow? Because it is getting streamed from 2 different server. So, that is why, right, we maintain one ID, that this ID will be unique for each user request, okay. For each user request, this ID will travel in each log, right. So, there are 2 types of ID, okay. Still you do not be confused, one is trace ID, another is span ID. Trace ID is global for all the services, all the servers. Span ID is unique for one server. I will tell all these things in detail in subsequent lectures, just giving one high level that this is one problem is there and this way we generally fix these issues. Another thing that may come, right, is the caching, right. So, if you have any static data, you can cache in both the server, that is okay, that is till now it is fine, right. If in memory cache, if you can cache it in 40 different server also, it will serve, that is not a problem. But in real time, if you want to cache some data, suppose you have a database and a user is frequently accessing the data, right. So, why you need a latency to go to each time to database and get the response done. So, in this case what we do, right, we generally store this data in a cache, right, and this cache next time when the users request the same, right, same user requests the data, we directly send back from cache, we do not go to the database, right. This database latency we remove it by using cache. So, what happens, right. So, in this case, suppose for the first user request went to S1 and in S1 server the caching has been done, right, and the next user request went to S2. So, S2 will not able to serve, right, S2 will again go to the database and send, right, because the caching happened in S1 not the S2. So, in this case also there is a problem, that is why what we do generally we maintain the cache outside of the server, that is called distributed caching. This is where the Redis is used for. Redis is just a NoSQL database, a key value pair database where we store the data for caching, right. So, I know this is going very high level for some of you guys, but do not worry, we will discuss all these things in subsequent lectures. Just understand in distributed system what are the problems may come, why distributed system gets little complex in the final design, okay. So, what we do? We do distributed caching. What we do? We maintain the cache outside of the Linux sandbox because caching in one server will not serve for different server, right. So, this is another problem. So, this kind of problems may come when you start scale horizontally to your applications, okay. So, there are a lot of other problems are there. This is the main problems which may help you to understand why we are using log streaming, why we are using configurations, distributed configurations, why we are using distributed caching. Just wanted to make you understand that these kind of issues you may face while you do the horizontal scaling. Okay. But with vertical scaling, this kind of problem will not come, because your applications will still be served under one particular server, right. But when your application will be served in multiple server, there will be such issues present. Okay. So, this is it for today. In the next lecture, we will understand, we still talked about application server scaling. We did not talk about database scaling, right. So, in the next lecture, we will understand how we can scale our database, right, because if you scale your application server to 40 different server, right, but if you have only one database serving to 40 other instance, right, your database will die soon, right. So, you have to scale your database also, so the database can perform sequentially with your server, right, because otherwise your 40 server who is giving 40 different connection to database and get the details, your database connection, right, bandwidth will be very slow and your database will die very soon. So, you have to what you have to do, you have to scale your database along with your application server. So, this is what we will talk about in the next lecture. Thank you so much for today. Bye bye.